Okay. So we're going to start with problem 6.13 from the book. So here we have a truss that's connected to a wall by a pin joint and a roller joint. So first thing we want to do, as always, is take the free body diagram of the entire structure. So the roller joint has one force going here. We'll just call this EX. And the pin will have two reactions. Call them AX and AY. And then we have a bunch of 1.2 kilonewton forces acting down on the structure. So we have to draw these in. Or sorry, 12.5 kilonewton. Okay. So those are all 12.5 kilonewtons, just to make that clear. And they're all 2 meters apart. So first thing we want to do is some of the forces in the Y. So be AY minus, and since there are 4 forces that are each 12.5, we'll just do, say, 4 times, sorry, 1 second, 4 times 12.5. Okay, so that's it. So then that's equal to 0. So if we multiply that out, we'll get, what is that, 50? Yeah, 50. So AY is equal to 50, and the units are kilonewtons. So now if we do the sum of the forces in the X, we just get AX plus EX is equal to 0. So we can solve that. So we want to do the sum of the moments to get the rest of the forces here. Okay, so where do we want to take the moment about? It's probably best to just take it about point A, because then we don't have to deal with things going in a bunch of different directions. It's just going to make it simpler for now. So we'll do some of the moments in the A direction. Obviously, there are multiple forces that are going through point A, so we can disregard those. So looking at EX, we end up with a positive moment due to that. So we're just going to say EX times the distance was 2.5. So that's just by a right-hand rule. And then the rest of these are going to give us negative moments. So minus 12 times 2 minus 12.5 times 4 and minus 12.5 times 6. And this is equal to 0. So we got to multiply this out here. Okay, so we end up with EX is equal to 40. So if we plug that back into our sum of the forces in the X equation, we end up with AX is negative 40. So now that we have all that, we can start looking at individual joints. So I think the easiest part to figure out first is just point A. Obviously, we know all the forces, we know multiple forces that are acting there, and the other forces are in the horizontal and vertical directions, so that'll make it easier to do the calculations. Actually, before we do that, it's probably better to figure out some of the lengths here. We don't know these lengths yet, so we're going to need to do a similar triangles calculation here to get these lengths. These are each 2. So to get BF, this is BF, this is CG. So we need to find those values there. So you can say the length of the side there, the length of AD over height AE is going to be proportional to 4 over BF. So that's just a similar triangles equation there. So this tells us BF is equal to 5/3 meters. And we can do the same thing to get CG. It's just going to be 2 over CG. So this will tell us CG is, let's see, 5/6. Okay. And so now we also want to try to figure out the numbers that are going in between here. So we have these 2 here. Okay. So let's start with just doing ED. So that's like the side length of the entire triangle. So this turns out to be a 5, 12, 13 triangle. So if we're to look at this like this, this side's 5, this is 12, and this is 13. Okay, so we want to do that for all of these diagonal numbers that we don't know what angles they're at. And I guess some of these aren't going to turn out very nice. So this one in here, let's just put in these other labels here. Going from E to B is not going to turn out nice. It's just 2.5, and then this is the square root of 10.25. So that's not going to be that helpful in our calculations, but we can, it's still nice to know what that is. Okay, so now we do the same thing, but this time it's with the length of BF. Okay. Again, we end up with something that is not very useful. So this is going to be 2 is 5/3, and then this is square root of 61 over 3. So again, this will we can just plug those in to try to get our angles here. So the next part of the problem, we just want to start at point A. So I'll get a new sheet out here. So we have point A here as a 12.5 kilonewton force acting down. And then it also has, we're going to say this is force AE and force AB. We're drawing these in tension, like always. And then we also are going to have the 2 reaction forces, which we just calculated. So that's going to be AY is 50 kilonewtons upward, and EX is 40 kilonewtons, or sorry, AX is negative 40. So you can just draw this in here. All this AX and AY. So again, pretty simple. Just some of the forces in the X. End up with AB plus AX is 0. If we look back on the other slide, AX was negative 40, so that just means AB is going to be 40. Okay, so that's the first truss member that we found. We're going to do the same thing. Some of the forces in the Y, we end up with it was AY minus AE minus 12.5 is equal to 0. Obviously, we know that AY was 50 kilonewtons. So if we plug that in, what do we get? We get 50 minus 12.5, which is 37.5. So that's the second solution. And that's all we can figure out from point A. So where do we want to go next? I guess we'll just go in order and go to point B now. So we have 12.5 kilonewton force acting down. Actually, I'm not sure if we can do point B. Let's take a look here. Yeah, I think we need to go to point E, actually. Move over to point E. This is point E. Yeah, force EX. Now we can do force AE going up, always in tension. Then we have force BE here, and force EF. Okay. And so we're going to need to use the values we found here for figuring out the angles that they're at. So if we do look at some of the forces in the X, actually let's start with some of the forces in the Y. some of the forces in the y. Let's see. Okay, so we're going to have 2.5 over the square root of 10.25 times BE plus AE plus 5/13 times EF. So we can't solve that yet. We don't know all of these. We don't know BE or EF. So we're just going to have to wait on that for a second here. So now we do some of the forces in the X. It's going to be EX plus it's 2 over square root of 10.25 BE plus 12/13 EF is equal to 0. So we know what EX is, we know what AE is, so we're going to have to combine these equations to solve for the two unknowns. So let's just think about how we want to do that. I guess since Professor Castle was going over problems on matrices, we can do it like that, just as an example. So to do that, we're going to set up our coefficient matrix here, and we're multiplying by BE and EF. And these are going to be equal to the opposite of AE. So what did we say AE was? AE is 37.5. So negative 37.5, and it's also going to equal the opposite of EX. EX was 40. So let's say that's negative 40. Okay, so BE here was just 0.5 over square root of 10.25. And then we had 5/13 here. Here we had 2 over square root of 10.25 and 12/13. To solve for these, we're going to need to do a matrix calculation, which you can do on your calculator. So let's just plug this into a calculator. I think Professor Castle said he would go into more depth about using Gaussian elimination to do this. I'm just going to plug this into my calculator for now. It would take a long time to do a Gaussian elimination on this, and we don't have that much time. So my calculator gave me the solution. BE is negative. Well, it gave it to me as a big fraction, so I'll simplify this in a second. And then EF is negative 65/4. So let me just write this as a decimal. We don't need that degree of accuracy. So it's just about negative 40.020, and units here are kilonewtons. And then here, negative 65/4 is just negative 16.25 kilonewtons. So there's two more answers. You could also do this problem by solving for one of either BE or EF in terms of the other in one equation, and then just substituting it in. So this way, I think, is just more compact. It's easier to write on this board. So, but if you have more room to write, you can figure it out the other way as well. So that's two more of the equations, or two more of the truss members that we know. So now we need to look at another point. So let's look at point B. Now that we know more information about this, about the forces here, we can figure it out easier. So we have AB, we have a 12.5 kilonewton force acting now. We're going to have a new force BC, new force BF, and then back to BE again. So the only ones we don't know here are BC and BF. So look back, make sure we remember what we did here. So BE was the negative 40.02 kilonewtons. And that's at an angle, so we're going to need to do components here. So let's just draw this back in. 2.5 square root of 10.25. So and the forces here, so it's easier. So BE we said was negative 40.02. And then we also need force AB, which we solved for, it was 40. So now if we do some of the forces in X, we end up with negative 40 due to AB plus BC, and then a minus 2 over root 10.25 times BE, which is negative 40.2. And this is 0, so we can solve for BC now. Just plug this into my calculator. And we get 15. So that's our first truss solved there. And now we can just do a sum of the forces in the Y to get the other number. So we have negative 12.5 minus BF minus let's see, so that the sum is 2.5 over square root of 10.25 times the negative 40.02 is equal to 0. So same basic thing here. We're just gonna plug this into a calculator, see what we get. Okay, so sorry about that. We got 18.75 kilonewtons. So that's the next solution. So now that we have those, we can move on to point C. Again, these problems are pretty tedious, but the actual calculations you're doing are really simple. So I wouldn't worry too much about getting these problems done wrong or anything like that. It shouldn't be too difficult for you. Actually, let's move on to point F. I think you have to do these in order from closest to the truck or closest to the wall. So we look at point F. We have the BF, which we just solved for. We have EF, which we solved for a while ago. And then end up with, as far as CF, which is at an annoying angle again. And then one more force here is FG. So now we get to deal with the annoying angles again. So let's look back, just make sure that we know what the angles are here. So that both EF and GF are okay. They're at the 5, 12, 13 angle here. Let me just draw that in. I'm just going to draw this whole thing bigger so it's easier to see. Okay, so this was CF. Sorry, these are supposed to be in a straight line. I'm having a hard time drawing this here. Let's try one more time. Okay. So this one is FG, this one is EF, and this one is CF. Okay, so this whole thing is the 5, 12, 13. So it's 5 up and 12 over. Okay, and then this CF is at some weird, like 2, 5 over 3 square root of 61 over 3. So let me just write that over here. So that 2, 5 over 3 square root of 61 over 3. Okay, so that's for CF. Okay. So now we can start summing the forces. Actually, let me just write in the values we have here. So we know that BF was, what is that, 18.75. And then EF is negative 16.25. So actually this force here can basically just be written as one force, or no, sorry. If you were to solve for FG, you would be able to write that as one force. So let's see. We're doing the sum of forces in the X. or let's start with some of the forces. No, I guess it doesn't matter. We're going to end up doing a matrix solution here. So again, we're looking for CF and FG, and since both of those are at angles, you're going to need to solve it either by doing a substitution or. So some of the forces in X give us 5/13. Sorry, negative 5/13 EF plus 5/13 FG plus, let's see, it'd be root 61/6 times CF. So I just got that. I took the root 61/3 and divided by the 2 that's in the X direction. So this will be, this is equal to 0. Some of the forces in the Y. We have BF minus here, I'll write this a little differently this time. This time I'll write it as 12/13 times FG minus EF. So it's just a little bit neater of a way of writing that, since those two are in the same direction. And then we're going to have a plus sorry, I realized I just made a little mistake here. You just check what the actual answer is here. Sorry, yeah, I just had this flipped. This is supposed to be 6/√61. So now when we're doing the calculation here, this will give us plus 5/√61 times CF is equal to 0. So again, I'm just going to plug this into my calculator into a matrix solver. That'll just make it easier to do here without doing a bunch of weird substitutions. Okay, so this is a little tricky because we know BF and EF, so we got to combine them here. So I need to break apart this bit here. So let me just rewrite this as right, this is just 12/13 times EF. Okay, so here we go. Just plugging that into a matrix solver, we end up with FE is, again, it's giving it to me in fractions, so I'll simplify this in a second. And then the other one, CF, is equal to okay, so this simplifies down to negative 47.367 kilonewtons. There's another answer, and then this is 15.579 kilonewtons. Okay, so we have to keep moving on to the next point. So the next point was it point C? Just write in the other forces here. And luckily, we know mostly, so this will make it easier to solve. So here we have CF. We just solved for CF. That was 15.579. And we had BC before. Let's see, BC was 15. And we also know that CF is at an angle here. Let me just draw this. This was 2 5/3 square root of 61/3. So we're trying to solve for CD and CG. So it doesn't really matter which sum of the forces we do first. So let's just do sum of the forces in Y is negative 12.5 minus CG minus 5 over square root of 61 times CF, which was 15.579. Okay, so this is equal to 0. This will give us CG is equal to negative 22.473. Okay, sum of the forces next. Is CD minus BC, which is 15, minus 6 over root 61 times 15.579 equal to 0. We can solve for CD here. CD we get to be 26.968 kilograms. So now that we have all that, what else do we need to solve for? So we need to count how many trusses there are, or how many trust members there are, and see how many we've solved for so far. I'm pretty sure we just need one more, since we've done all except for 2 points. So let's see. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 trust members. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need one more to get that. We're just going to look at point D. This should be really simple here, since there are only 2 members connected to it. CD and DG. The only thing we don't know here is DG, so we can just do a simple sum of the forces in the y direction. This is 5/13, or negative 5/13 times dg minus 12.5 is equal to 0. So dg is negative 32.5. And that's the end of the problem. So there's quite a bit of work. Hopefully the next problems won't take as long because we don't have enough time to. We won't have enough time to get through them. They didn't take too long. So let's see. Okay, so as usual, just start this problem by taking a free body diagram of the entire thing. So there's a pin joint here, we'll put 2 forces. Roller joint here, we'll put 1 force, Gy. And then we have 2 forces acting down here of 6 kips. So obviously if we do some of the forces in X, we get AX is equal to 0. So we don't need to worry about that anymore. Some of the forces in the Y gives us AY plus GY minus 12 is equal to 0. Then we need a sum of the moments. We'll just do about point A. Get negative 6 times 18 minus 6 times 36 plus 54 dy is equal to 0. This gives us gy is 16/3 kips. And AY is 20/3, based on our sum of the forces in the Y equation. So now we can just start looking at individual joints. Well, glad I mentioned this problem's a bit easier with angles here. All of these are going to be 3, 4, 5 like this, or if they're going the other way, it's going to be 3, 4, 5 like that. So that makes it quite a bit easier for doing calculations. So I'll just create a new slide here. So we'll look at point A. We already said that the force in the x direction was 0, or the reaction in the x direction was 0. So let's just look at AY here, which we just said was 20/3. We have AB and AC. So if you do the sum of the forces in the x direction, that will give us AB. Or sorry, sum of the forces in the y direction will give us AB. So this is 4/5 AB plus 20/3 is 0. AB is negative 25/3 kips. Some of the forces in the x is 3/5 AB plus AC is equal to 0. So we'll give us AC is 5 kips. So now we want to look at point B. So we have an AB here. Sorry, I drew it backwards. Whoops. All these forces, we're just going to draw on tension. So this is AB. This is BD. This is BC. So we need to solve for BDC. Some of the forces in the Y give us 4/5 times AB, which we just let me start the list here. Okay, so 4/5 times, it was a negative 25/3. Plus, sorry, these are both minus. Should just make that clear here. So minus 4/5 BC is equal to 0. So this will give us BC. Let me just plug that into the calculator here, check what it is. So this turns out to be 25/3 kips. And then we can do some of the forces in the x. It's equal to BD plus 3/5 BC.
The one again?
Yeah. Minus 3/5 0. So we need to solve for BD here. So it's just going to be 3 over 5 AB minus BC. So this gives us negative 10 kips. So now let's move on to the next one. We'll look at point C. This time we're solving for C and CE. Some of the forces in X. So we'll start with some of the forces in the Y. It's equal to 4/5 BC plus 4/5 CD. So this just tells us BC is the opposite of CD. So CD is, what did we say BC was? 25 over 3. So CD is going to be negative 25 over 3 kips. Some of the forces in the X, we have CE minus AC plus 3/5 CD minus 3/5 BC is equal to 0. So we're solving for CE. So back, see what this. BC is 5. We just said BC was 25 over 3. So let's just plug those in. We get 15. So we got to keep moving on to the next point. Point D. Force DE. Force DE. Force C. And force D. It looks like we're out of time for today, but if you just keep going through the forces like that, you'll get it.